All right. Hello, everybody. My name is Zach Parnell. I'm the VP of Operations here at ITI. I want to welcome you all here. We're probably going to be having some folks entering the proverbial room here as we get started, but I want to just introduce our speakers today. We're really excited to be doing this today. We've had about 3 of these webinars, and I'll kind of go over that, but the host, Mike Parnell, is the ITI President CEO, and we've invited Jim Yates to speak today. He's a Senior VP of Engineering and Technical Services at Barnhart Crane and Rigging. And the reason we did this, with the whole purpose of the ITI Showcase webinar series, is to bring, insight and just cool information and cool presentations to our customers and friends and prospects and different folks that are trying to learn about ITI or know about ITI. So we have a lot of, I know Mike and Jim will probably touch on some of the folks in the room. We've had I think we had about 300 folks register for this event, and probably very excited to see Jim speak. I'm not going to toot his horn too much and make him all nervous, but he's a great guy. You guys should really get to know him and meet him. He's going to be speaking basically on heavy intermodal lift and transport. I saw this presentation in December in Mobile, Alabama at the Maritime Lifting Workshop that we put on with Barnhart. And it was just an awesome, awesome presentation. So just to get in really quick to the presentation and who ITI is, if you've never heard of us, we really focus in the area of crane and rigging training and consulting through a bevy of industries with operations in Canada and the U.S., also Brazil and Peru. And we're working in Singapore and Asia Pacific quite a bit and working on a few opportunities in Eastern and West Africa. But the neat thing about what we do is a lot of customers obviously come from a variety of backgrounds, industries, from aerospace to wind energy, as you can see here. And I'm not going to spend too much time on this, but you'll kind of see who we're about, as we go through this presentation with Jim, and Mike will be on the presentation as well. But a lot of the world's leading companies come to us for this very specific training in advanced rigging and lifting applications, as well as crane operations, et cetera. So to give a little bit of background before we get started, there's some past presentations y'all can go and view as well. Today, obviously, it's the heavy intermodal lift and transport. We've done 2 presentations that are recorded on the website that you can go view and also download the PowerPoints. Those are up top there, the past presentations. And also, in the next 3 months, we're pretty excited about the upcoming presentations regarding the Master Rigger course, lift planning considerations, and then ASME B30 and P30. So let me present really quick the guys that are going to be chatting with you today. This is Mike Parnell. He's got over 30 years of experience in the rigging industry. Him and Jim both are very, very involved with ASME. Mike is the vice chairman of the ASME B30 main committee. And the P30, which a lot of you might not have heard about, is the Committee for Lift Planning. It's a new committee. Mike will probably touch on it a little bit. I believe Jim is involved in that one as well. And then Jim Yates, very neat background. He's going to be speaking for the bulk of the presentation today. And again, this is his presentation, but he's actually a U.S. Naval Academy graduate in BS in Aerospace Engineering. And he was in the Navy for, I believe, 7 years. As a nuclear and Navy officer, and then he was working at Tennessee Valley Authority for 7 years there in the 90s and earned a senior reactor operator's license. And I've never heard the full story. He might enlighten us a little bit today how he came to join Barnhart, but he's really a mastermind of a lot of their critical lifts and you guys will see what they do. They pretty amazing company and how they operate and the things that they accomplish. So it's a really neat fact is, in they are 25-time winners of the Rigging Job of the Year award, while Yates has been at Barnhart. That's given out by the SCNRA. So for no further ado, I want to turn it over to Jim. He's going to basically take over the presentation here. And hang with us, guys, if we have any technical difficulties. Jim Yates is actually in Memphis right now. And Mike and myself were in Washington State, but he's going to take over the presentation and go through it, and we're going to take questions as they come in. You guys can post questions to the discussion board, and then Mike and Jim will be handling them at the end of the presentation. So take it away, Jim.
All right, Zach. Hey, Zach, what screen are you seeing right now? Because we'll click.
I got your, the presentation I have with the engineering considerations right on top.
All right, make sure I've got it. Here we go. All right, Zach, are you seeing the main presentation? You're still seeing the notes?
Nope, main presentation.
Super. Well, thanks again, Zach, for your kind introduction, and I also thank you for the opportunity to continue sharing knowledge and information about our industry. As many of you guys know, a vast majority of the heavy equipment like generators, transformers, and heavy-walled vessels are manufactured overseas now, which means they arrive in the U.S. at some port, and then they've got to be transloaded to other means like barges or heavy transporters or rail to reach its final destination. And so we designed this presentation to cover the engineering considerations associated with this intermodal movement of this type of equipment. So the outline that we're going to be covering today is the need for engineering on these type of moves. We're going to cover the boundaries in which of the topic itself. Then I'm going to go into the engineering considerations associated with things like the lift plan, the heavy lift ship, the environmental considerations we've got to take into in our lift plans. We're going to talk about the load handling equipment, or what they call LHE now, the rigging associated with lifts, and then the transport of the equipment itself, whether it's by barge or rail or heavy lift trailers. And then the last thing I'm going to cover is a real quick topic called management of change. So heavy loads require additional diligence to ensure safe delivery. It isn't like in a lot of the plants or factories where they're basically skilled to craft lift plans that go on every day by skilled iron workers or maybe stevedores in just everyday bulk freight type of activities. When you deal with the heavy load, you really have a lot more things to take into consideration. Things that we normally might take for granted, like the dock strength, has got to be evaluated. Proper engineering analysis is going to help us to prevent accidents associated with these type of heavy equipment that comes into the U.S. and these ports. Also, just as a little side note here, you see my friend here being lifted up because they messed up the center of gravity. Here at our company, we have a thing that we say we don't want to look like Fido's rear end when we do our lifts. Obviously, we want to be safe, but we also don't want to look silly. And you can see here these guys over here having a Fido moment as they've loaded their cart too much and have actually picked their prime mover off the ground. So heavy marine and lifting transport's a very large topic, and I want to try to set a boundary for what we're going to talk about. We could literally spend days discussing all the elements that really need to be considered. So what we're going to do today is we're going to limit our discussion to just the engineering that's associated with heavy cargo. Usually that is equipment like heavy wall vessels or generators, from offload from the ship to a transporter or a rail. We're not going to consider all the things associated with offshore maritime lifting or things lifting in open ocean or even underwater lifting environments, even though those things may come into play sometimes when you're talking about maritime work. We're also not going to get into all the operational considerations either. You've got a lot of things other than engineering to consider when you develop these lift plans. We're not going to go into all those. I'll touch on some of them, but mainly I'm going to focus on the engineering associated with the work we're talking about. All right, so the first engineering consideration really is the lift plan in itself. And all heavy maritime lifting and transportation really does require that you have a lift plan. The lift plan, which a lot of people now are calling method statements or project plans, they should cover all the aspects of the lifting and transport of this gear. In engineering, the thing we're talking about today is just one of the many aspects that are covered in a lift plan. So I'm not going to go into all the things in the lift plan. I'm just going to say there should be a complete comprehensive lift plan associated with this type of heavy movement of this equipment. And the engineering is just one of the many pieces that fall in play. There's a lot of good guidelines that are out there that talk about lift planning for maritime work and for intermodal transport. Noble Denton, if you're not familiar with them, they're like a tech service provider to the oil and gas industry, and they've written a lot of really good standards out there from everything from tie-down considerations on open ocean barges to what should be involved in a proper lift plan for heavy equipment. There's also two other organizations out there that also have similar guidelines, the International Maritime Organization and the International Marine Contractors Association. Also, if you go online and Google them and look at some of their information, they've got some really good guidelines that are out there as well for developing the lift plan. So the first, other than the lift plan, now let's start talking about specifics. Let's start looking at what our ship considerations are going to be and the engineering associated with it. And we're going to talk about four areas. We're going to look at the LHE associated with the ship. We're going to look at the position of the ship associated with its position on the dock. Then we're going to talk about ship stability, and then we're going to look at some of the strength requirements associated with these big heavy transport ships, and some of them are called ro-ro ships, and where we're going to look at the ramps. So a lot of the ships that come into port, like this big one here, are equipped with heavy lift cranes and derricks in order to do a lot of the self-load and offload. And you see here we're offloading a pretty big piece here. The load charts on these ships really need to be reviewed in relation to the lift and the set radius of the loads that you're working with in order to ensure that the lift is planned within the capacity of the cranes on the boat or the ship. If the ship's not equipped with an adequate LHE, then a lot of times you've got to find alternate means to make the lift off of the ship onto some other conveyance. And that may require going to a port where there's already a heavy lift crane available, like this one here. This is in the Portomobile. This is our barge crane. Or you may find, like Houston's got one as well, or there may be a big dockside or floating crane that's actually being used to service heavy lift ships that come in into these ports. What's really important on these LHEs on these ships is that you look at the inspection and maintenance records associated with the gear to make sure it's ready for service. A lot of these ships travel all over the world. They're subject to a lot of environmental degradation, and in order to be safe, you really want to make sure that these ships are ready to make the lifts. So inspection records and maintenance records are good to look at. And sometimes you may even want to do a load test. If you've got a high-risk lift or something that you're picking that's a one-of-a-kind or has got like a very long lead time to replace it if something were to happen, we have seen where we've done actually test lifts with the ship's gear to make sure it's ready to go when you offload your prized possession on that dock. You see here, here's an accident that happened a couple years ago. I believe this was in the port of Los Angeles, where the LHE load cable actually separated. It hadn't been properly cared for, and it parted the line, and one of the two cranes dropped its end of the ship, or end of this big vessel. It was a heavy wall vessel that fell on the dock. So it's really important to make sure that these inspection records and maybe a load test is done to again prevent this kind of accident from happening. The dock position is another thing we want to look at besides the LHE on these ships. If the ship position can be really critical in making sure you've got a good lift efficiency. If you arrive there to make your lift onto your trailer or your rail or whatever it is, and the ship's in the wrong position and they've got to reposition it, it can mean that your lift maybe really have to be delayed. It costs money. So improper lift position can also invalidate that whole lift plan you just put together. So a lot of coordination's got to happen between where you want to put the ship in order to make a proper offload. You can see down here where my mouse is kind of circling around here, this lower left-hand picture, that's Big John down in the Port of Houston, and they're lifting a 325 metric ton sulfur recovery unit, and you can see he's offloaded it from a ship and now he's bringing it to a barge. So all that positioning is really important to make sure that the dockside LHE or the ship's gear position becomes a really big deal for these guys. So we want to make sure we communicate once we figure out what the capacity of the LHE is on the ship, to make sure we actually position the ship so you can use the LHE properly, whether it's a barge crane like Big John or or something off the dock or the ship itself. Ship stability is another major consideration you've got to look at. In the ship stability, you know, these are very big vessels. I mean, you're talking about 1,000 tons moving off a ship like this. You can run into problems if you're not paying attention to your stability during the lift. And you see in those two pictures, those are both vessels that weigh over you know, 1 million pounds. And so you can imagine as they take it out of the hull of the ship and they start bringing it to the dock, the ship has got to spend a lot of time making sure the ballast is correct and all those things. So ship stability has got to be maintained the whole time here, because heavy loads can quickly affect the ship's stability to stay upright during its lift. Usually the ship's crew is going to determine the ballasting plan to maintain stability, but this plan should be part of your lift plan and should be properly communicated to the lift team. Sometimes if you've got a complicated or high-risk lift, it's a good idea to get a naval architect or a marine engineer to validate those ballasting plans. Here's a couple of pictures I want to show you where stability failures of the ship can be disastrous. This was an accident that happened in Albany, New York in December of 2003. This ship was loading heavy components, power plant components, going out of our country somewhere else, and they lost control of the ship's stability as this power plant equipment was getting on board the ship. And you can see what happened. The pieces in the hull looks like they shifted, and it caused the boat to become unstable, and she tipped over. And the 3 men that were on the boat making these lifts were all killed. So ship stability is a very critical factor with these heavy loads that we're talking about. All right, let's talk about the ship strength. For the sake of our discussion, we're really just going to talk about the ramp strength. The ship that's in this picture here is what they call a row-row ship, or roll-on, roll-off ship. And what it does, it allows you to take heavy loads directly from the dock up onto the ship itself. And a lot of times it's safe to assume that the ship owners have already accounted for the structural strength to support the heavy load on the boat while it's transporting. And so what the heavy transport company's got to do when they take possession of the load is to communicate the loads that they're going to put on the ship's gear. And most of that's dependent upon what gear they're going to use. So like in this case, this picture right here, platform trailers are the thing that are typically used for doing these high heavy load transports off of these ro-ro ships. And so depending on the number of lines that you've got on these things, these platform trailers, the axle loads have got to be taken into consideration to ensure that the ramp design isn't invalid. And so there's lots of ways you can fix that. If you use too small of a transporter, it might be good for the load but not good for the ramp. So you can maybe put more axle lines underneath it and spread the load out better. But again, it's got to be communicated very clearly with the ship and the dock, because there's reactions in the dock that you got to consider, and we'll talk about that a little bit later in detail. But in this case, that ramp has got a design limit, and we want to make sure that we don't overload the ramp. Another thing to note in this picture right here, you can see where I've circled those beams that this thing's sitting on. This is really not an engineering consideration as much as it is a coordination note. A lot of times in order to save money, the shipper and the transport company can save our customers a considerable amount of cost by coordinating their efforts. In this case, what they did on that ship was they had it up on beams and stands. And so that allows this transporter to drive directly underneath it and pick it up without having to jack the load up or spend a lot of time with alternate lifting gear to pick it up so the transporter can get underneath it. So this is a way to save and be efficient in our movement of these big loads. All right, other than the ship, we got to consider a lot of environmental factors in our engineering considerations. And the things that we're going to be looking at are weather-related environmental considerations, tidal and current effects, and then some environmental laws that are really impactful in our operations. So let's look at the first environmental thing, which is wind limits. Most LHEs have got limits associated with where they can do conductive operations. And that normal limit is based on a particular size and weight for a load. And a lot of times it isn't anywhere near the size of like this vessel shown in this picture, where you're talking about a very big vessel with big sail areas. So in that case, you may have to take special considerations, and this is where an engineering team can come in and coordinate and look at the sail area and the requirements of the side loads that a big wind would impose on those LHEs, and make sure that the LHEs have got a proper limit established for the lift to make sure we don't get into trouble with wind speeds. You've also got wave limits you got to consider when you're doing environmental considerations for these heavy lifts. Wave height is definitely going to impact the ability of the LHE to make the lift. And if the boat's moving around, or in this case like this barge mounted crane here, there may be some very severe limits on even in the port for how high the wave's going to get. So you've got to know those in advance. That's part of your lift plan, and you want to be able to say, guys, here's the limits of our wind, here's the limits associated with the wave action that's happening even inside a port for conductive operations.
Jim, if I can interrupt you just for a minute, this is Mike Parnell. We had a question from Jeff St. Amand with AEP on the experience exists for roll-off barge unloading on Lake Michigan and other Great Lakes, and this seems to be about the location where he might have some concerns or consideration. You might comment on that question, please.
Yeah, that's a good point, Mike. If I understand right, some of the considerations on the Great Lakes for maybe a roll-off or for unloading the ships. And in the Great Lakes, there's lots of things you have to consider, because they're not, even though it says lake behind it, it's anything but a lake. You know, if you guys have been up in that area and been on the Great Lakes, they're considered open ocean. And so everything from the tie-down restrictions, which I'm going to talk about a little later, to the transport engineering associated with deck strengths and things, all has to be open ocean. So that's one consideration you've got to have. And then the weather up there has really got to be looked at in detail. Plus, you've also got other things up around the Great Lakes to be considered, like how you actually get into the Great Lakes, whether you're coming into the St. Lawrence waterway, which is big, or maybe you're coming up to the Mississippi and you got bridge areas that are got low-hanging bridge like the Lamont Bridge, moving into the Great Lakes up through the Chicago area. And then you've got considerations associated with the beaches themselves. Some of them are very shallow, and you can't, you know, we had a job, Mike, where we had to consider removing a reactor out of Big Rock Point up off the one of the I guess it's the Thumb area of Michigan, and you couldn't get a barge in there because the water was so shallow. So Great Lakes work does take take a little bit more thought than just your basic roll-off at a dock, because there aren't very many heavy offload areas in the Great Lakes. There's very few docks that were designed for doing heavy transport, and so all these things, what we're talking about here, kind of come into very keen focus up in the Great Lakes area. So I hope that answered your question.
Yeah, thanks, Jim.
All right, other than wave restrictions, the other thing we got to look at for these when we're coming into ports or moving things up rivers and wherever we're taking our piece to offload it is tidal and current conditions. The timing of the lifting and transport operations can be critical in some of these areas. Like if you're up in Maine, we had a lift up in Maine where the tide was swinging. In a day, it would move anywhere from 8 to 10 feet. And so with that kind of tidal movement, you really have to consider things like your mooring, and your water depth becomes really critical, as well as station keeping, because with that kind of tidal swing, you also have some very strong currents going on. And so as you're trying to roll off, the last thing you want is to be rolling off of a barge where the back end is moving around, and now you've got a real disaster on your hands where you could actually drop the load. So all these things have really got to be considered heavily in your engineering. Hey, Mike, you may want to mute yourself there, buddy. Somebody's got pretty high mic load coming in.
Okay, we'll check it on our end. Go ahead, Jim.
Okay. Environmental restrictions also with local environmental laws is a big deal to look at. A lot of the ports in the U.S. now have rules associated with ballast discharge. And even though this may not be engineering, it's still got to be part of your All right, sorry about that. Looks like I got muted accidentally. Okay, let's get back to it. So we're talking about ports in the U.S. that have rules associated with ballast discharge. Engineers have got to know these rules because a lot of times you've got to consider the ballast position for these barges. So you're going to be adding water during the roll-off and the roll-on, which is part of the barge considerations that we're going to talk about here later. So knowing what the rules are in these local areas is important. I think it's well organized for you. All right. The thing that's important to note about these rules is sometimes you can take on water in one port and you can't discharge it to another port, which is a big deal. So you want to make sure that you know those rules. So when you get, like if you were coming into the Port of Mobile and you were going to go offload up in the Great Lakes, there's restrictions associated with the water transport discharge from one of those bodies of water to another. So you may have to do all your ballasting in Mobile and leave the water in it. So you want to make sure you're ballasted for your roll-off even before you get there. All right, let's talk about common LHE considerations. Now that we're done with our environmental, let's go into the LHE itself. And these would be more, not the ship's LHE, but things on like maybe our barge-mounted cranes and things. So let's talk about load charts and equipment configurations, pretty common to all LHEs, regardless of what you're using. The load charts, like static and dynamic effects, have to be considered. A lot of times when you're lifting on water, you may have a local requirement, or you may, for sake of conservatism, want to consider dynamic effects in your lift plan. And some of those can be pretty considerable. If you start looking at a 10% dynamic impact factor on your load, and the load's really big, you can push yourself away from one size of crane into a whole other category, which might mean considerable amount of cost to the end user who's actually paying for the services. And so also there may be some local restrictions. A lot of refineries nowadays will limit how much of the chart they're going to allow you to use, so you need to know those things before you do your engineering plan. And then your engineering plan's got to consider it. Mike, we're still getting a lot of feedback, brother. I don't know if anybody else can hear it, but we'll carry on, but if you guys can wipe it out, that would be great.
It's pretty good.
All right, let's keep going. The equipment configuration, another thing to consider here. You've got the jibs and the counterweight on the cranes are different. You may have a mobile crane up against your ship that you're using off. You've got to consider. You've also got multiple cranes that might be doing, so the configuration of those cranes is important. And then your clearance issues like the load and the LHE itself, making sure you've got adequate clearance as you pick the load and move it around.
The organizer